Have you ever been tricked by the media in order to believe their narrative? Have you ever been tricked? Well, if not, then you are lucky, and if yes, then you are sincere. The thing is that nowadays we are experiencing a very fruitful period where the media can easily trick the normal or the average person into believing whatever horror story narrative they're trying to sell. And since we are undergoing a pandemic, one of the more popular topics is the one concerning mortality among those who were treated or medicated for that specific pandemic. So let's assume the following problem. There's a newspaper that publishes the following title: 70% of those who have died in the hospital were medicated. Oh, it's pretty bad to be medicated. What the newspaper doesn't really tell you is, or if they don't tell you out front, they might tell you in the content of the article, but they should also tell you what's the ratio of people that are actually medicated out of your total population. So without further ado, we are gonna use Bayes' theorem and some basic conditional probability reasoning in order to assess how much worse or better off is a medicated person when it comes to their chances of survival or, uh, positively speaking, not dying. That's kind of important. So what the media is telling you is they're giving you the following ratio out of the total uh, dead population, which for the sake of example I have drawn here in this ellipse. So these are medicated but dead people, these are unmedicated dead people, and this is the total set of dead persons. The media is simply telling you the ratio of this magenta set as a size of a set or population count divided by the total count of dead people. Kinda macabre, but that's life. Sorry for that pun, it was not intended. And you should also know, or it's given in most cases, that there's a certain percentage out of the total population of people that were medicated. So these people over here were medicated as opposed to these other ones that were not. Now, how do we actually get to leverage Bayes' theorem, which is given over here? So you can find it easily if you Google. We will leverage this to shed some light on our primary question. What's our primary question? So we've established that we know this fact out of the population that is registered as dead, a certain amount was found to be medicated. So you read this as follows. Given that someone has died, how likely are they to be medicated? All right. But that's not very useful because I want to know how likely it is for a medicated person to die. See, it's not really the same thing. They're not equivalent because this equation actually relates the two items. Now, what does it mean to be dead and medicated? Well, it's all about counting these guys up here. They are dead and medicated, and the probability of selecting a medicated person out of this dead people pool, sounds bad, but well, it's just mathematics, can be expressed as such. It's this item here. So the probability of a dead person of being medicated. It's not the same thing as we mentioned as the probability of a medicated person of dying. No, the probability of a medicated person of dying is equal to the probability of a dead person to be medicated times the general probability that any person dies of the disease, so medicated, unmedicated, both of them, divided by the probability of selecting out of the total population a medicated person. So it's the size of this M set up here divided by the size of the total population. That's our M, and it's given as a subunitary ratio. So if you are patient and write everything algebraically, you will end up with these equations. So in the end, what you are interested in knowing is how better off or worse is a medicated person as opposed to a non-medicated one when it comes to their chances of dying. So that's this ratio here, meaning given that we have someone that was medicated, how likely are they to die, and divide that by the likelihood of a non-medicated person to die. So that ratio, it can be computed and is equal to this nice amount. So T, if you remember, was the ratio of medicated people among the dead, and M is the ratio of medicated people among the total population. These are values that you can read in newspapers or hear on the TV or radio or whatever. But it's useful that you pay attention and you by yourself quickly assess how bad the situation actually is. Now, in order to actually get a feeling, a sense of that nastiness of the situation, I wrote a very small script that can be used to actually evaluate that factor that we discussed previously. So if it's more likely for a medicated person to die as it is for a non-medicated one, well, things are bad and you should not take the medication. It's utter crap. So what you see here on the X horizontal axis, this is the actual T parameter, meaning the percentage of medicated people among those who have died. So I know they're dead and they're medicated. Now, Y is the percentage of medicated people among the total population. Not the same thing. So let's see. Let's take one of these points in this blue region, which is the nasty region for people that are medicated. Let's take a sample. X is 0.5, so that means 50% of those who have died are medicated, and Y is 0.32. That means 32% of the population was medicated. That's kind of bad, and it means it's 0.44 times as better to be medicated than unmedicated. So it's worse. It's actually worse. Don't get medicated. But let's take some samples from this region. What do we see here? Well, X is 0. Let's get here 0.54. So 54% of those who have died were medicated. So we have more dead people and medicated people than unmedicated dead people. That's bad, right? Well, let's see. 73% of the population is medicated, but given our formula that we've discussed previously, it's actually 2.3 times better. If you are medicated, you stand higher chances of not dying. Contrary to what you read in the media and what your intuition tells you, even though there are more dead people that are medicated, you see on overall, a medicated person stands more chances of surviving than an unmedicated one, just because of these ratios and how they work. This is nonlinearity at play. Now, let's get further to the right where things kinda get nasty. So 73% of the population, of the persons who have died were medicated. I repeat, 73% of the medicated population, no, 73% of the dead population is medicated. See, I almost tripped myself. I repeat, out of the dead, 73% are medicated, but 81% out of the total population were medicated. Is it actually that bad to get medicated? Well, it's not. It's 1.6 times better, or your chances are 1.6 times higher to survive if you get the medication. Now, if things are slightly different, for example, 84% of those who have died were medicated and 81% of the population was medicated, then no, the med doesn't work. It's actually crap. You're better off without it. So in essence, this is what this nice scatter plot tells you, how much better it is to get medicated as opposed to not get medicated if you want to survive. Well, obviously, the best scenarios are towards the top left corner, meaning the fewer people among the dead that are identified as medicated, and the more medicated you have, then the better it is in terms of survival chances for the medicated ones. And how much better? Well, a lot. For example, in this case, where only 12% of those who have died were medicated, and your population is 78% medicated, then the medication increases your chances of survival 25-fold, as opposed, between a medicated and unmedicated person. So that's 25-fold. Remember, 12% of the dead are medicated, and your population is 78% medicated. 25-fold. So next time you think it's easy to reason about such things, remember this nice formula. Here it is. This very nice formula that tells you in one go everything. So, yeah, you only need T and M. I repeat, T is the ratio of medicated people among the dead, and M is the total ratio of medicated people out of your entire population. That's it. Rather simple.